Hello, and in this video, we're going to talk about the last possible type of degrees of freedom, that associated with rotation. Now, for a diatomic molecule, modeled here as usual with a pair of atoms connected by a spring, we've already discussed a few different types of degrees of freedom. The molecule has three so-called translational degrees of freedom, three ways in which it can move: front, back, left, right, and up and down. It also has two vibrational degrees of freedom, effectively one associated with the speed of vibration and one associated with the size of the vibration. We'll be exploring these a little bit more later in the course. But there's another way I can add energy to this molecule. In addition to making it move or vibrate, I can make it spin. And for a diatomic molecule like this, there are two different ways I can make it spin. I can make it spin about this axis here, like this, or I can make it spin about this axis here. So that's two. You might say to yourself, but what about the last one? What about, where it spins about this axis? Well, that comes back to our discussion from the basics of matter. As we saw there, in an ideal gas, the molecules themselves have no actual size. And this is true even for like a molecule, because relative to the size of the molecule itself, the nuclei that are most of the mass are effectively zero size. So this kind of doesn't count for a diatomic molecule because the atoms are so small. In contrast, if I have like a polyatomic molecule, like water, for example, here's my oxygen and my two hydrogens, then I do have three rotational degrees of freedom. I can spin this way, right, about an axis perpendicular to the screen. I can spin about this axis, rock on, or I can spin about this axis and have it spin this way. So in that case, there are three. So in general, for complex molecules, there would be three. Diatomic molecules, you lose one because this doesn't count, but the other two do. And for, single monatomic gases, like the noble gases or something, they don't spin. And the reason they don't spin is, again, because in our model of an ideal gas, which of course has limitations like all models, they have no size. And for reasons that are a little beyond the scope of this course, if you don't have any size, you can't really put energy there. So that doesn't count for a monatomic gas like helium or something, by the exact same reason that taking a diatomic gas and spinning it this way doesn't count. So to summarize up, you get 1 degree of freedom for each axis about which you can rotate, where the molecule has some size. So diatomic molecules have size in two directions, can be rotated in about two directions where they have size. Polyatomic molecules like water have three. And monatomic gases, because they have no size, have zero. This concludes this video.